It's great to see so many of you all. I'm Maria Cutter, and I'm the Sustainability and Climate Specialist at CoolSeal. So we are recording, as Davis said, and also you can use the chat as we go through, and we'll answer those questions live or at the end. So for our program today, we are going to have, I'll give share a brief overview of the webinar series, and then we'll go to the presentations by our wonderful speakers. And then we'll give a quick overview of some CoolSeal updates and news, and then have our questions. So we launched this webinar series last year because we saw the need to share information about what's going on in the heat space from mitigation management standpoint, as well as what people are doing to protect the communities from extreme heat and the dangers that they pose, as well as heat waves and just the temperatures are going up over time. So we are all working on different aspects of solving that problem and identifying the best strategies to reduce heat and also manage and help people stay healthier. And so the idea is that we want to bring these strategies, bring everyone together and connect you all with experts, subject matter experts that can speak to these concepts. It's a way to connect you guys with subject matter experts that you may not otherwise know about, and also to give you access to speak with them firsthand and hear from them about their great work. So we're spotlighting a broad range of experts to this end, knowing that there's no silver bullet. And we want to focus on trees and greening, great way to reduce temperatures, probably the best, one for one, has its own challenges. Then, of course, reducing waste heat, that's getting now a lot of press because the higher temperatures, then of course, folks use more AC, which emits heat, uses fossil fuels, etc. And of course, cool and reflective surfaces, roofs, walls, and pavements. We are featuring today two excellent speakers. We have Dr. Glenn Hulley with the NASA Jet Propulsion Laboratory, as well as a featured special guest, Beth James Bourgeois from the Cool Roof Rating Council. And as I said, Davis will share some CoolSeal updates at the end, and then we'll go to questions. So Glenn is with us today. We're very excited. He was able to take time out of his busy schedule to join. And I've had the good pleasure of working with Glenn over the years on projects. And he's an amazing, brilliant scientist and researcher. He has done so much work and a lot of heavy lifting to get the specialized equipment, monitoring equipment up onto the International Space Station. And I believe there's more heading up soon that Glenn has helped develop and work on in that way. So not only that, he then takes that information that comes down, the satellite imagery, and is able to use it to pinpoint hotspots and track them, and not only in the States, but also around the world, and use that information then to help identify what heat mitigation solutions are working and to the effect that they are working. Another unique trait of Glenn's is that he has the ability to take this highly technical information and make it digestible and easily understandable for everyone. So please join me in welcoming Glenn Hulley.
Okay, so you want me to go ahead and share?
Yes, please go ahead and share.
All right, can everyone see that?
Yep.
My first slide? Okay, good. Thanks for the introduction, Maria. It's really nice to be here, and it's always a pleasure for me to present this type of work. A lot of the time we get involved with the nitty-gritty of science and technical aspects of our job, but it's really nice to show the data actually in action, or what we call NASA's called Earth to Action presently. So the presentation I'm going to show you today are kind of like a broad highlight summary of the results that we've obtained from thermal infrared remote sensing with respect to imaging urban heat over the last decade or so. I'll show some examples of how we can identify fine-scale urban hotspots, identify heat inequities within cities with a focus on LA, and then also look at some quantifying at some actual heat mitigation efforts, such as the application of street bondings and other cool roofs. So just some context here. Urban heat continues to increase with climate change. For example, 2022 was a record-breaking year. In fact, these slides are a little old because 2023 was actually broke the record for the hottest year so far. But in 2022 was Europe's hottest summer. A number of cities breached their temperature records, exceeding 40 degrees Celsius for the first time, such as Rome in Italy. Here, closer to home in the US, the September heat wave, famous Labor Day heat wave on the West Coast, it was the hottest heat wave ever on record in the Western US. It spanned more than 10 days, breached 100 degrees Fahrenheit on almost all 10 days in a very large area of LA. And it's really a harbinging of things to come, because what we've shown is that urban heat waves are rapidly increasing in all of their metrics that we monitor. For example, their frequency, their duration, their intensity, and whatever type of heat wave model or metric we look at, we can see a sharp rising increase in all these metrics over time, especially in the 21st century. Now, this brings with it a lot of human health impacts. For example, if you look at the NOAA hazard statistics, you can see that heat is actually the largest killer in terms of natural disasters in the US, and far surpasses the deaths from, for example, floods, tornadoes, hurricanes. And on the right is an interesting image and result from our colleagues at Caltech that showed, using the land surface temperature measured from satellites, which is what you see in the color there, you can see that the daily ER visit rates really rapidly increase during these heat waves. And these also strongly correlate with household income. For example, it's the poorer communities that experience not only the hotter temperatures, but also the greatest risk from extreme heat. This was a study in Los Angeles. Now, how can we monitor the changes in heat and heat exposure throughout the urban environment? Throughout the last sort of 20 years, we've been using primarily thermal infrared instruments and spaceborne thermal instruments from NASA satellites. So moving from left to right, we started with very coarse resolution satellite data of about 1 kilometer or so, since about the year 2000 from MODIS and VIIRS. And then more recently, in 2018, we launched EcoStress to the International Space Station. This was an instrument developed here at JPL. It has a number of thermal infrared bands or spectral windows that we measure the radiation from. It has about a 3 to 5 day revisit, so it'll pass over LA about every 3 or 4 days, I believe. And the spatial resolution is around 70 meters, so greatly enhanced from the 1,000 meters that we had back starting in 2000. And so you can think of a small football field, a kind of scale in terms of its actual pixel resolution from space. We also have HITEST, which is an instrument that we fly on aircraft in dedicated campaigns around mostly the Western US, but also in Europe and other parts of the world. This is also a JPL instrument developed here at JPL. It's a hyperspectral instrument, so it has 256 bands as opposed to the 5 from EcoStress. It's used in dedicated campaigns and has a very high spatial resolution, 1 to 10 meters, depending on the flight altitude that we fly at. And so at this resolution, we can really zoom down into the temperature of an individual house or individual tree within an urban environment. And so these two instruments results will be the main focus on the remainder of my slides here today. In the future, we are currently working on the next generation EcoStress, if you will. It's called SBG. It will launch in 2028. It has more bands, more consistent repeat cycle and also a high resolution at 60 meters. And so this will be our sort of next generation thermal infrared high resolution instrument. So from EcoStress, just some basic fact here. It measures the radiance in 5 bands. It was launched in 2018, June 2018 to the ISS. Again, it has a spatial resolution of about 70 by 70 meters. And the fundamental science products that we use and develop from that data are the land surface temperature and the emissivity. The land surface temperature will be the main focus today. And it's a lot of people get a little confused. It's not the air temperature that we feel, as humans, but it's the actual skin temperature of any surface that you would touch with your hand on the ground of the surface. From EcoStress, we have a wide variety of different science and applications that we've applied the data to. For example, monitoring heat waves. We can measure the SO2 emissions from volcanoes. We can monitor droughts by estimating the water usage of plants and other vegetation. And we can also monitor wildfires in almost near real time and map their trajectory as they burn through vulnerable areas. A lot of people don't realize, where are we in the electromagnetic spectrum in the thermal infrared. So, the visible light that we see as humans is roughly between 0.4 and 0.7 micrometers. This is the location where the sun's intensity is at its maximum in the UV. But what we're measuring is around 10 micrometers wavelengths. And this area is called the thermal infrared. And so any object with an absolute temperature will be emitting thermal infrared radiation, including us, as humans. And so it's this radiation that we measure, and then we're able to back out and extract the temperature that object was radiating at. And it happens to be the 10 micron range happens to be right in maximum sort of radiometric emission from Earth-like temperatures at around 300 degrees Kelvin, which is around 25 degrees Celsius. So this is one of the first sort of science highlights that made the media. One of our first images actually from EcoStress happened to be during an extreme heat period in LA, of course, at the end of July, early August. And for the first time, we were able to see temperatures across different times of the day. And this is because on the ISS has a very strange precessing orbit that comes over at different times every other day. And so for the first time, we were able to actually observe the temperatures in an urban environment from space at the early hours of the morning. For example, the image on the right here shows the temperatures at around 4 a.m. And so what really struck us here, which was pretty startling, is that you could see the temperatures of mainly transportation networks, roads, freeways, large paved asphalt areas. These are the temperatures that are still really hot and still radiating, even at those early hours of the morning. And this is particularly important because it's the nighttime heat that has the biggest consequence on human health. Since then, we've had many media requests over the last couple of years to generate similar images and quantify and look at urban heat islands over different parts of the world. We've regularly done a lot of images over Europe and different cities of Europe as requested by the European Space Agency, and of course a lot of cities in the US as well. This is another really nice image over LA. This is during the September 6th heat wave 2022, strongest heat wave ever on record on the West Coast. And what's really striking here, this again a nighttime image, you can see moderating influence of the coastal regions, of how much cooler they are than the inland regions, which are more insulated from that cooling effect. So you can see in San Bernardino, so the road surfaces, anything paved, is still very, very hot, around 30 degrees Celsius, even almost at midnight. We've worked quite a bit with the Climate Resolve group here in Los Angeles, which a lot of you, I think, are aware of. For example, we helped them map out the hottest streets in the Skid Row area, which is notoriously the region with the highest homeless population in LA, about 8,000 people. The city then took that information and they were able to use it to optimize the areas to distribute water during extreme heat events, here shown by these stars, which is a nice application of the data. On the right, this is another really nice study by our colleagues at Caltech that showed that it's generally the lower income communities areas have not only the highest temperature, but the less green space. And that trend results in about a 3-degree heating for every 50,000 K of household income, which doesn't seem like a lot, but every degree really counts in terms of human health when it comes to these extreme events. Again, this was from data using the eco-stress data and then other sociodemographic data within the city. We then took this a step further, and I worked with my postdoc here at JPL, and we decided to look at the redlined areas in Los Angeles. These are areas, it was a practice that was implemented in the 1930s, in fact, where areas were segregated according to their desirability to live in. For example, the red areas here were less desirable than the greener areas, where the green areas were easier to obtain loans and mortgages and so forth. And generally, they were associated, the poor communities were associated with people of color. And so what we did was we took the eco-stress data, the land surface temperature, we took the average heat wave summertime temperatures across the entire record of eco-stress, and then we mapped those onto these redlined different regions here on the left. And what we found was that if you look on the bottom right here, if you look at the histograms, kind of not unexpectedly, it was the most hazardous or declining redline regions that experienced by far the highest heat relative to the wealthier neighborhoods, anywhere from 15.5 to about 15 degrees Celsius. And in a paper that we recently submitted, we looked at this over a different number of seasons. We looked at the hysteresis curves and we had a lot more intensive analysis on this. But in general, it's the hot summertime temperatures that create the largest disparity between these different income groups. Now, getting into eco-stress again, and one of the things that we really worked a lot on was sharpening the data down from the coarser resolution, which is 70 to about 100 meter level pixel size from eco-stress down to about the 30 meter level, which enables us to start seeing more finer detail within the urban structure. For example, we can discriminate the cooling area of a golf course from the freeway, and we can see individual roofs, for example. And we do this by using visible near-infrared imagery from other satellites at a higher resolution than the thermal infrared. I'll go into a little bit of detail of this a bit later, but the results I'll show from now on are from this sharpened 30-meter higher resolution data. And so this really enabled us to really zoom into the urban environment and start seeing some fine level changes, for example, from heat mitigation efforts. This was a slide that really has been used a lot over the last few years by the LA City in demonstrating the effects of the cool street bondings over different parts of Los Angeles. For example, this shows Stephanie Drive in the Winnetka neighborhood in the San Fernando Valley. This street was painted in 2018, I believe, and this eco-stress image was taken in 2020. And we could distinctly see the sort of arc of cooler temperatures that coincided with Stephanie Drive and the offshoot streets here that were painted with CoolSeal back in 2018. And I worked very closely with Greg Sparks over the last couple of years. He's no longer with the city of LA, but he's in Seattle right now. But he initially called this his $4 million image because he used it to advocate for more money from the state to implement more cool roads and other heat mitigation efforts. Subsequently, over the next couple of years, he received another $2 million for shade trees and then another $2 million federal earmark in 2022. And so it started becoming his $8 million image. And this really advanced a lot of the cool street heat mitigation efforts in LA. For example, they were able to move to more machine-applied coatings instead of using human labor. This drastically reduced the cost by about an order of magnitude, and they were able to cover a lot more ground. And then they were also able to obtain a lot more funding, as I just said, to implement these street codings in a lot of different areas. And this just shows an example on the right of where they focus more on the underserved areas in Los Angeles. So in the metro area, southeast LA, and then part of the San Fernando Valley. So moving on to the high test, which is our airborne instrument here at JPL, which really allows us to now zoom in at the tree to street level of the temperatures within the urban environment. It flies on the Twin Otter. If we want to get the high resolution data, the Twin Otter is a twin aircraft you can see on the bottom left here, and also on the ER2 aircraft, which is NASA's high altitude aircraft. But in general, we fly roughly at about 6,000 to 10,000 feet, which is around 2,000 meters. And this gives us about a 3 to 5 or so meter resolution on the ground. In LA, unfortunately, because of the ATC and the very dense air traffic, we actually have to fly at 10,000 feet, which gives us roughly about 5 meter resolution. We fly on dedicated campaigns, and similar to EcoStress, we have the land surface temperature and emissivity as our main products from the instrument. But because it's hyperspectral, we're also able to detect trace gases such as methane and other SO2 emissions from factories, for example, within the city. We're also able to look at crop water usage by implementing the LST in crop water models. So on the bottom left here shows the flight lines that we flew in 2021 and 2022 over LA, specifically targeting these mitigation efforts from the city involving street bondings and also the tree planting. And these were, one-day missions, so we were piggybacking on other larger campaigns in the area. And what was nice is that we tested undetected by flying over these streets in LA. We do have some other flights planned. For example, this August, we plan to fly almost the entire LA basin, which is really exciting. This will be the first time that we actually acquire data over the entire LA region. But this is what our flight lines look like. They're roughly about 2 kilometers wide at about 10,000 feet. And this just shows an example of the temperature over downtown LA at the 5 meter scale. So what's really nice with high test is that we have the resolution now to actually do a classification of temperatures solely based on surface type. For example, on the plot on the right of Pasadena, you can pull out a region of a suburban environment. And if you pull out the temperatures and look at the histograms, you can see that it's during the daytime, in any case, it's the roofs on homes that are by far have the largest temperature, sometimes exceeding up to 70 degrees Celsius. That's followed by the local roads in the neighborhood, yeah, shown in black, and then of course trees and other vegetated surfaces are much cooler. And so actually in 2014, I believe, yes, it was Climate Resolve that helped pass a policy with LA City where they mandated cool roof standards for all newly constructed homes and also renovated new homes. And this was adopted by LA County as well in 2018. But it really just shows that most of the heat during the day occurs over these roofs, which have a very low thermal capacity, and then they cool down very rapidly at night. But conversely, it's the roads that heat up and stay really hot during the nighttime because of their higher thermal mass. So this is just a map showing some of these flight lines from high test over the areas I just showed you. We actually have a few more to the north that I'm not showing here in Silmar and other areas. The white sort of little specks or white lines here are information I got from the LA City on roads that have been painted since 2018. And it's very useful because we can use this to plan future flights, but also look at the actual dates of when these roads were painted to be able to look at before and afters, for example. So just briefly here, the one thing that we do with the high test data of Los Angeles to try and sort of scale them down to an even finer resolution, we use a similar method that we do with EcoStress, where we use a random forest machine learning model to sharpen the data down to finer resolution using higher resolution visible near infrared data. And in this case, this is actually pretty recent work that we've been doing. We use data from Worldview 2, which is developed by Maxar. It's a spaceborne instrument with about 8 visible near-infrared bands. And so on the right just shows 2 example images from Maxar, where we use the reflectance data and also the normalized vegetation index data at around 2-meter resolution to sharpen the high test data down to about the same resolution of about 2 meters. And so you can see just this freeway interchange here. I think this was the 210 and the 10 interchange. It looks a bit fuzzy at the 5-meter scale. Nevertheless, you can still distinguish the roads from each other. But it's really at this less sub 2-meter scale that we can start pinpointing the temperatures of individual trees, and also much smaller roadways between the homes. And the way we do this in the machine learning model is we correlate the NDVI, the vegetation index shown on the left here, with the albedo, which is another word for the reflectance and the visible shortwave infrared, and then the temperature, which I'm showing here in color, mapped onto this scatter plot. And so you can see there's actually quite a nice relationship between these 3 variables. The green vegetation has a high NDVI and low temperature. And then paved surfaces within the urban environment both have low reflectance and low NDVI and high temperature. And then reflective roofs and also roads, if you will have a higher surface reflectance and a lower temperature. And so that machine learning model learns those relationships and is able to sharpen the higher, coarser resolution temperatures down to the finer scale. So I'll just end off now with showing a couple of examples over some of these streets that we've looked at so far. One of the first streets ever painted actually was in this area in Southeast LA over Lord Street. This was in July 2018. And so this is a zoomed in image of the high test data. Again, this is 2-meter resolution. And what we've done here is we've draped it over Google Maps so you can see kind of the background transparency of the type of surface that we're looking at. And so on the far left, you can see Lord Street, which was painted in 2018, and Mark Street and Clement Street, which were not painted. And you can see that Lord Street is a couple of degrees cooler than the other asphalt roads that weren't painted. It looks like about 4 to 6 degrees cooler. And so this is really nice to see with high tests, is that we could pinpoint these temperatures, down to the sub-road, sub-meter level. When we actually quantify that, what I've plotted here is the temperature on the left for the 2 streets and the reflectance on the x-axis for Clement Street and then Lord Street on the bottom right. And you can see this 3 to 6 degree drop in temperature, and also you can see it's more reflective at the same time as a result of the CoolSeal application. So this is a really nice result to see. First off, just the first street we looked at with high tests over this area, and also just shows the longevity of the paint itself. This was looking 4 years on now, after a lot of probably road traffic and other wear and tear over the years. We can see a couple of other things in this image. For example, the tree shading here on Mark Street, in the middle of Mark Street. This is a late afternoon acquisition, and so we see a lot of shade onto that street and significant cooling from the tree line there itself. And so, just planting trees in itself is also a great way to is a great heat mitigation technique within the city. Also notice here just the difference in temperatures between a set of homes here without any trees and a set of homes with a lot of trees in their neighborhood. We see anywhere between 10 and 15 degrees cooling just by having trees in your yard, creating shading, increasing the evapotranspiration, and cooling the air in the region. Okay, so moving to the next area here, this was in the San Fernando Valley in the Winnetka neighborhood area. This is one of the first sort of neighborhood scale street paintings that they implemented. They painted, several blocks of streets. This was in 2019, I believe. And so the streets here that you see with sort of the white markings, these were the painted streets. with CoolSeal, and you can see they range between about 40 and 45 degrees Celsius. This was actually a very hot day. This was a heat wave day in August 2021. And then the two unpainted streets here, you can see are much hotter, anywhere between 45 and 50 degrees Celsius from the high test data. So an even larger difference here of up to 10 degrees between the painted streets and the regular asphalt streets when the temperatures get even warmer. I'll end off with this image. Again, I showed this image earlier on Stephanie Drive, which is the first image we looked at with eco-stress data and quantifying the effect of the cool streets. We now have high test data, and so this is high test data 2 years later from the eco-stress acquisition over the same area where we've zoomed in here. And so what I've highlighted here is with eco-stress, we saw about a 2 degree or so cooling effect. That is because the pixel sizes were about 30 meters, so much larger pixel size. So you're averaging other elements within that pixel, and so the effect of the cooling from the pavement itself is reduced somewhat. With high test, we can zoom in all the way down to the sub 2 meter scale. What we see is about a 6 degree cooling effect from Stephanie Drive to, for example, CRRC Drive here, which you can see is much redder, much higher temperature. And if we can quantify that, what I've plotted here is the temperature of, CRRC Drive on the left and then Stephanie Drive on the right. And on average, Stephanie Drive is around 7 degrees cooler within the margin of error here. So significant cooling, and it's actually kind of within the magnitude of the cooling that we've seen just going around with thermal cameras on the ground and looking at the differences between the cool street and the paved street. And so that is really cool, is that we can actually quantify from remote sensing airborne data a similar magnitude of cooling that we see if we had actually make ground measurements. And that's really significant because we can cover a lot more ground from remote sensing than we can just by looking at point measurements on the ground. So I will stop with that, and if there's questions, I guess we'll leave it till the end, or I'll also jump on chat right now and answer any questions that anyone may have. Thank you.
You are muted.
Thank you, Glenn, so much for that amazing presentation. It is fascinating to me to see the advancements and the way that you're able to lay your imagery over street data. It's just fascinating. So thank you for that. And thanks for staying around for questions too. All right, so now we will take it over to Beth James Bourgeois from the Cool Roof Rating Council. Beth really runs the show over there on their Cool Walls rating program, which is brand new, and you'll hear about that. And she's also very hands-on and works with licensees as they go through the process of applications to also becoming certified. So, and they're lucky to have her too as a liaison. So without any further ado, we'd like to welcome Beth.
Thank you. Let me go ahead and share. Okay, Maria, can you confirm you can see my screen okay?
Yeah, everything looks great, Beth. Thank you.
Okay, perfect. Great, thank you for the introduction. As Maria said, I'm the program manager of the Cool Roof Rating Council, where I manage both the roof and wall rating programs. I'm sure a lot of you are most familiar with our organization as providing third-party ratings for roof products. But as she mentioned today, I'll go into an overview of the CRRC's wall rating program. But before I go into the details of the program, I just want to provide some highlight some benefits of cool exterior walls and how they help combat urban heat islands and improve energy efficiency. Cool exterior walls are one solution in addressing the impacts of extreme heat. They're often a cost-effective approach where the benefits can be felt immediately. Cool exterior walls reduce a building's surface temperature and ambient air temperatures by strongly reflecting sunlight and efficiently emitting absorbed heat. Lower surface temperatures reduce the individual building's solar heat gain and resulting indoor temperatures, increasing occupant comfort by keeping the building cooler during hot summer months. This helps reduce the need for air conditioning and cuts energy costs for building occupants. And in buildings without air conditioning, cool exterior walls can help the interior be more tolerable during hot times. This is especially impactful for older existing buildings, which tend to have less insulation than newer buildings. So on a community scale, reducing air conditioning needs during the hottest part of the year improves grid stability and decreases demand on the electrical grid during peak times, reducing brownouts and blackouts. And cool exterior walls also help to mitigate the urban heat island effect. The greater the number of buildings in a given area with cool exterior walls, the lower the outdoor ambient air temperature will be. In addition, decreased AC use from cooler indoor temps helps reduce the amount of waste heat released into local environment by AC units. Among other things, this helps improve air quality by slowing the production of ground level ozone, which contributes to smog formation. And at a global scale, cool exterior walls help raise the global albedo and reduce greenhouse gas emissions from electricity generation to power AC. The metrics that determine coolness of an exterior wall are solar reflectance and thermal emittance. Solar reflectance being the fraction of solar radiation that is reflected by the wall surface, while thermal emittance is the relative ability of the wall surface to re-radiate any absorbed heat. Both properties are rated and measured on a scale of 0 to 1, with 1 being the most reflective or most emissive. And as Glenn was mentioning too, the urban heat islands, just kind of overviewing these, the urban heat island or UHI effect is a phenomenon caused by a high concentration of dark impervious surfaces such as roofs, walls, parking lots, and roads combined with a lack of green trees and green spaces, which cause cities to be hotter than the surrounding rural areas. Tall buildings that block or slow air movement, known as urban canyons, contribute to the formation of heat islands, along with waste heat released by vehicles and air conditioning units. Urban warming is a critical challenge that can have a multitude of negative impacts, including human health, quality of life, energy use, air quality, social equity, and economic prosperity. And as previously mentioned, heat has a big impact on energy use and air quality. When it's hot outside, AC use increases, which puts a strain on electrical grids, which can result in blackouts and grid failures. The increase in AC use also produces more waste heat, which only adds to the heat problem. So higher outdoor temperatures also decrease air quality by slowing airflow and increasing ground level ozone, which contributes to the formation of smog. And the increase in cooling demand from AC use can result in the use of peaker plants, which are large emitters of pollution, air pollution. So as previously discussed, cool exterior walls can be an important tool for helping to mitigate the growing impacts of heat on our communities. And third-party ratings provide end users with credible, easily accessible data to inform consumers about rated products' ability to reduce heat gain and identify products that comply with codes, programs, and standards. So that's where we come in. The CRRC wall rating program was created to meet this need for third-party ratings, and I'll now go into an overview of the program. Just briefly, before I dive into the wall program specifically, I just want to take a second to provide a brief overview of the CRRC as a whole. So the CRRC is a third-party rating organization. We were established in 1998 as a 501c3 nonprofit organization. And we were created in response to California Energy Commission need, Title 24, Part 6. As such, the CRRC is the designated Title 24 supervisory entity for roofing products in the state of California. The CRRC evaluates and labels the radiative performance of roofing and exterior wall products. And we provide a public service through product ratings, research, and education, which supports development of policies and programs centered around energy efficiency and mitigating the impacts of the UHI effect. And we do this by publishing the radiative performance ratings of products in an online directory. And that data are used by policymakers and program developers to evaluate policy options, incentives, and programs. And though the CRC ratings are used in the development of policies and programs, the CRC does not advocate for specific requirements. And also, we don't provide a certification. We don't have a threshold that needs to be met. Regardless of the value, the rated products are listed on our directory. The CRC is also an ANSI accredited standards developer that maintains an American national standard that's referenced in many codes and programs. And we're also an ISO 17065 accredited certification body. So there's actually 3 core areas of the CRRC, and one of them is providing third-party ratings of radiative energy performance of roof and wall surfaces that are fair, credible, and accurate. Another part is supporting research into energy-related radiative properties of roofs and wall surfaces. And we also provide education and objective support to parties interested in understanding and comparing various product options. The CRC added wall ratings to our mission and bylaws in 2019. And for several years, a highly collaborative group of stakeholders from the wall industry, government, national laboratories, and many other sectors worked together to develop our wall rating program. And the program was officially launched on January 17th, 2022. We have a diverse and balanced wall rating program committee that continues to oversee and improve on the program. The wall program is administered in accordance with the CRRC2 Wall Product Rating Program Manual. This is a proprietary document first published in 2021 and contains all of the participation requirements, technical criteria, and test methods for measuring the solar reflectance and thermal emittance of wall materials. And updates to the CRRC2 are implemented as needed, and they do require a recommendation from the Wall Rating Program Committee and then approval by the CRRC Board of Directors. And the manual is available online at coolroofs.org. And CRC wall ratings are obtained in accordance with consensus standards and industry vetted test methods. The product ratings are based on radiative property measurements made by accredited independent testing laboratories, referred to as AITLs, which are ISO accredited test labs that are approved by the CRC to perform testing for our programs. In some cases, approved manufacturer testing laboratories can also submit product rating data for the color family program. These laboratories undergo a thorough application process to demonstrate compliance with program requirements. So an AITL takes initial measurements on new product samples, which then go to accredited test farms in 3 designated US climates to naturally weather for 3 years, after which they are tested again by an AITL. Any exterior wall product can be tested to obtain a CRC rating. There's no minimum solar reflectance required to obtain a rating. And on screen, you'll see there's an image of the 3 different climate zones where rated products are weathered, and those are Ohio, Arizona, and Florida. And more information about product testing can be found in the Wall Program Manual or on our Testing FAQs webpage. So I briefly mentioned the Color Family Program on the previous slide. The Color Family Program is a rating option that allows manufacturers to group products that are from the same product line and are very similar in color under a single rating. Color family ratings are available for architectural coating and factory coated metal products. We also offer compound ratings. This rating option allows products with the same surface formulation that are offered in a variety of shapes or profiles to be listed as the same rating. And any product type is eligible for a compound rating. And then we also have products that are private labeled, for which we offer reference ratings. With permission from the original manufacturer, reference ratings allow privately labeled products to inherit the rated values of their parent product. Reference relationships, though, are completely confidential and don't appear any differently on the rated products directory. And this is an image of our directory. So active products rated by the CRRC are listed on the rated wall products directory, which is located on the CRRC website. The directory contains initial and 3-year aged ratings and is available free of charge to the general public. While the wall rating program is relatively new, our roof products directory currently has over 3,000 rated products and is the only roofing product radiative properties database in the US. And likewise, the wall directory is also the only one of its kind, now currently has 89 rated products listed. In addition to the wall directory, rated products are identifiable by the CRRC product label and rated product logo. These may be used on product packaging and literature to demonstrate your CRRC rating. Product labels contain the solar reflectance, thermal emittance, and CRRC ID, while the logo simply denotes that a product is rated and end users can look it up on the directory. So companies who would like to have a wall product rated must first apply to become a CRRC licensee in the wall program. Once approved, the licensee would submit a product rating application to the CRRC and coordinate testing and weathering with an AITL and test farm. More information on this process, including application materials, instructions, program fees and dues, and the steps to rate a wall product are located on the CRRC website. And you can scan that. That will take you to the wall rating program page. So there are many other ways that you can get involved with the CRRC other than becoming a wall licensee and having products rated through our program. One of which is becoming a member with the CRRC. More information on why to join and member benefits are located on the Become a Member page of the CRRC website. While you're there, also check out, we have a page on our annual meeting, which is open to members and non-members, and it's coming up on June 5th. Also, anyone's invited to be added to our wall committee mailing list, which you would receive periodic updates about the program, invitations to the wall committee conference calls. You don't have to be on the committee to attend one of the calls. You can feel free to sit in anytime. So if you'd like to be added to the mailing list, you can just email me. You can also follow us on social media. We post regular updates about the wall program and other CRRC activities. It's a great way to stay up to date on the program. And you can also be added to the general CRRC mailing list, where you'd receive periodic updates about the organization, our quarterly newsletters and updates. And you can visit our website at coolroofs.org for more information on any of these ways to get involved. You can also contact me directly at beth@coolroofs.org if you have any questions about the wall rating program or any ways to get involved with the CRRC. And I'll go ahead and pass it back over to Maria.
Thank you so much, Beth. Appreciate the presentation and the information on the Cool Wall program. It's exciting to see you all venture into that route. And, obviously we're talking about mitigating heat through multiple solutions and cool walls, cool roofs, obviously cool pavements, trees, all those play an important part. And, the more solutions we can come up with, the better. And I'm excited to see your all's continue to work on that. I know it's still the early stages compared to what you all have done with cool roofs, but exciting to see that development and hopefully some other things down the road too.
Yes, definitely.
Awesome. Well, thank you again. And I have a quick slide here just to kind of go over some things. We are celebrating our 10th year of municipal applications of CoolSeal, our first application of CoolSeal on a municipal asphalt pavement was 10 years ago in Los Angeles at Balboa Sports Complex, which is that first photo on the top left. And it was funny, as Glenn was talking there, I kind of found myself going down memory lane, seeing Lord Street, seeing Stephanie Drive and all those, remembering being on those streets. And I thought about putting that crescent on one of my pictures here, but I knew he would probably have it brought up, and that's something that many of us in the cool pavement industry have seen a lot of. And I don't know, not to go down memory lane too much, but that Stephanie Drive street was very impactful, obviously from the data that Glenn has collected, but also from leading to where the cool pavement industry is today. There was a Urban Sustainability Directors Network convening in LA in 2019, and sustainability directors from all around the country went out to Stephanie Drive about 6 months after we had applied that coding there. And that's where I had met many people from different municipalities that have now done cool pavement pilots and programs. Most notably, probably is City of Phoenix. I met Ruben Lawley from City of Phoenix out there, and City of Phoenix now has a massive cool pavement program, and about the size of LA, is a little bit larger, in fact, and that really helped spur a lot of the growth within cool pavement industry at the municipal level, just seeing the impact that we're having at that street, and it also was one of the impactful things that Glenn's work was able to highlight, and so it's really cool to see the impact that one neighborhood project has really had on this industry. But I digress. So 10 years on, we've now applied over 60 million square feet of CoolSeal across 23 states and 6 different countries. We've had some great partners that have done some third-party testing. Obviously, the great work that Glenn and everybody over there have done at NASA JPL. We've had some great partners from universities. Arizona State University has done an extensive study with the City of Phoenix Cool Pavement Program, and has continued to produce great results from that. So we're seeing a continued industry-leading temperature reduction, and I had not seen some of those slides that Glenn had shared, so it's really cool to see that 5-6 years on, we're still seeing those temperature reductions, which is great. And we are embarking on some new municipal projects for 2024. Some new cities are coming online. We've got some projects going, and I think Glenn highlighted a really good point too about the mechanization of the application. We've got a picture here of our most recent and our state-of-the-art application we're doing. We're using computerized rate control systems to apply product at a very rapid rate, at a very precise rate, and at scale that we can apply at a very low cost, and cover neighborhoods quickly, and also reduced impact on residents during construction, because obviously the less time you're working in a neighborhood, the better, and we're able to do that. And this piece of equipment is really revolutionizing that and kind of taking it to the next level. And that's just a little bit of kind of where we are 10 years on from CoolSeal, and some things coming up. We'll have some more information on those municipal projects in our next webinar that is taking place in July of this summer. We are going to be having Dr. Caleb Dresser from the Harvard School of Public Health joining us. So just as a little teaser for you all, we'll obviously have communication going out about that as it gets closer to the event, but look forward to hopefully seeing you all at that webinar. And with that, any other questions that we get in the chat, we can go through here. And I'll start looking through the chat. I don't know if Maria, if you've seen any that you want to call out. I will, as I've been talking, I haven't seen the chat, but I'll dive back into the chat. But I don't know if there's anything that you wanted to ask to the group, Maria, that you're seeing in the chat possibly while I look.
Okay, Davis, yeah, I see your answer to Melissa about the environmental, and you may also want to touch on the stormwater. We've gotten a lot of questions, or I can touch on it. We've gotten these questions about stormwater runoff from a number of different entities that are interested in the same question because they're coastal. And the answer is that once the CoolSeal is installed, it becomes inert and it is stable. So there's not going to be, any flaking or chemical release associated with water hitting the surface. And in fact, water hitting a cooler surface is better, on the aquatic life and aquatic systems, and rather than running off hot surfaces, such as untreated asphalt.
Yeah, absolutely. And I think it's Melissa's question was great because, I touched on it in the response there, but, really putting CoolSeal in areas where I have low shade trees and that sort of thing. If you look at that neighborhood project that's on that photo there, very wide open streets with not a lot of shade that is providing any cooling. And City of Los Angeles specifically, and other municipalities as well, are planting trees in neighborhoods as they're putting cool pavements and CoolSeal on them. And those trees obviously take some time to develop a canopy, but the idea is that once that canopy is developed, that there's not as much of a need, but you get that immediate impact as you're bridging the gap between waiting for that canopy to develop and wanting to reduce heat now, and that sort of thing. There was a question about we are recording this. This will go out to everybody that's registered, so you can see the webinar after the fact. let's see.
There's a
ahead, Mary.
question for Beth. Let's see, these are the chats. Is anybody looking at the Q&As? There's a few different ones in the Q&As. There's a question for Beth about the availability and use of some of your graphics. If memory serves, those are available for the public to use, right?
Yes, you can definitely use
Okay.
our graphics to cite the CRRC. If you just email me at beth@coolroofs.org, I'm happy to send those your way.
Janice Barnes in the Q&A asking for a recommendation of who to speak with in LA. We can get with you on that after the webinar. I've got your email from your registration. And then Glenn, this would be for you. Are you seeing any differences across the different types of vegetation, i.e., green space, grasses versus trees? Are you able to distinguish that on your data assessment?
Yes, we actually have done a study on looking at irrigated versus non-irrigated vegetation in LA, and there's actually a paper on that. But I think that is with eco-stress, but there's a very, very large difference between watered vegetation and plants and just natural vegetation in terms of their temperatures and cooling effects. With high-test, what's great now is that we can actually zoom in and look at the individual tree canopy temperatures and assess the health of more mature trees. But as Dave said, a lot of the newer saplings that have been planted as part of heat mitigation efforts by the LA City are still not observable at our sort of remote sensing scales. They're not mature enough yet.
Jennifer DeCoco is asking, is the heat data available to municipalities within the U.S.? Glenn, I know that when your instruments fly over the U.S., would you say every couple of days in L.A., how much is that able to cover the rest of the U.S.? Where else can we see that?
Yeah, so if you're talking about eco-stress, we get an observation every 3 days or so over any part of the US. And so let's say once a week, we can cover almost the entire US. With the airborne data, it's more sporadic and depending on campaign flights. So with LA, maybe once a year, at best. But all the data is publicly available. If you just search high-test, NASA, order, or eco-stress, you'll find the JPL landing pages for those satellite data sets, and then you'll be able to access the data anytime.
Awesome. Let's see. James is also asking about the public health improvements and should the skin temperature be coupled with WBGT and or other resources to better understand human impacts? That's a Glenn question.
What is WBGT, if I may ask?
Wet bulb, I have to guess.
Wet bulb. Oh, okay. Yes, so that's a pretty loaded question, but we're spending a lot of time on using the skin temperature and modeling up to get to the air temperature or the wet bulb temperature or the heat index, sometimes also called, is what we actually feel as humans on a hot, humid day. And so there's a lot of work going into that. We have a lot of models that we use to try and estimate that sort of skin humidity impact from the satellite data onto what we feel as humans. But it's a very difficult question because there's a lot of different factors involved, as you can imagine.
All right, thanks. Let's see. You guys, we've had so many robust questions in the chat. What we'll do, this is being recorded, and then what we'll also do is get these chat questions printed out with the answers, and we'll send that, make that available as well with the speaker presentations. So thank you guys so much for joining us today. As Davis said, our next webinar will be held at the end of July with Dr. Caleb Dresser from the Harvard School of Public Health. He's doing some amazing work there as well. So please be on the lookout for information about the next webinar, and we'll send the information around to you guys. So, and thanks again to our fabulous speakers. All right, bye guys.
Yes, thank you, everybody.
Thank you. Bye.